Good day guys. Today I will discuss about air conditioning and refrigeration equipment, single motor compressor, branch circuit calculations. This is still part of the electrical fundamentals that I am going to discuss for the design, installation, and maintenance. So this is still a part of the design stage. So before anything else, I want to ask you to please or kindly subscribe and click the like button and click the notification bell and select all so that you will get all my new upload videos for your reference. My topics to be discussed today are the code rules and the related calculations. So number one, I will discuss about branch circuit conductors. Number two, branch circuit, short circuit, and ground fault protection. Number three, disconnecting means. And number four, motor compressor and branch circuit overload protection. So this is the code rule for the branch circuit conductors. So for single motor compressor, the code says branch circuit conductors supplying a single motor compressor shall have an ampacity not less than 125% of either the motor compressor rated load current or the branch circuit selection current, whichever is greater. And for a Y-start delta run connected motor compressor, the selection of branch circuit conductors between the controller and motor compressor shall be permitted to be based on 72%. So this is either the motor compressor rated load current or the branch circuit selection current, whichever is greater. So how this 22% is taken? So actually, if you have a Y connected motor, the line current is equal to the phase current. So you will use the factor directly multiply 125%. But if the motor is a Y start and a delta run, so when the connection is in delta, the line current will be equal to the phase current in delta multiplied by 125%. So in this case, the current in the delta leg is 57.7% or 58%. So by calculation, 58% times 1.25, you will get 72%. So that is informational note mentioned by the code. Now let us also compare the two different currents. This is defined by NEC. So the first one mentioned was the branch circuit selection current. So what is this current? This is the value in amperes to be used instead of the rated current in determining the ratings of motor branch circuit conductors, disconnecting means, controllers, and branch circuit, short circuit, and ground fault protective devices. Wherever the running overload protective device permits a sustained current greater than the specified percentage of the rated load current. The value of the branch circuit protection or the branch circuit selection current will always be equal or greater than the marked rated load current. So this is different from the rated load current. Now let us see the definition of rated load current. The current of a hermetic refrigerant motor compressor resulting when it is operated at the rated load, rated voltage, and rated frequency of the equipment it serves. Now let us also see the physical comparison between a normal motor and a hermetic motor compressor. So this is an example of an induction motor. See how it looks. Um, Actually, there is a winding inside, and it is not completely enclosed. There is an air flow from outside to the inside of the motor winding. While in an hermetic refrigerant motor compressor, as you can see, this is a fully enclosed motor inside this container. So the big difference is this motor compressor will easily heat up as compared to this normal, like this induction motor. So let us take an example, a nameplate given here. So as you can see, this is the nameplate of a hermetically closed motor compressor. So this is 42 divided by 12. This is a 3.5 ton motor compressor, and it is given here the RLA, or the rated load amperes, is 17.9, and the LRA, which is the lock rotor amperes, is 112 amperes. Also, as you can see, this is the minimum circuit amperage, which is 24.1. This is the branch circuit selection current. Now for the calculations, going to the branch circuit conductors. So basing from the details from the motor compressor nameplate, and with the wide delta starting, branch circuit selection current is 24.1. It is greater than the rated load amperes, which is only 17.9 amperes. So I of conductor is equal to 24.1 times 0.58 times 1.25. So 72% is taken by multiplying 0.58 times 1.25, that is 0.72, or 72% as mentioned by the code. I conductor therefore is 17.5 amperes. And using the table, which is the conductor ampacity table, you can get the conductor the size. So you have to go back to my previous videos, which shows how to size or how to use the table for sizing conductors. So therefore here, using that table, we have to use 2 by 3.5 square mm, either THW 75% degree centigrade or THSN 90 degrees centigrade standard copper conductors with 25 ampere ampacity. By the way, I use here the National Electrical Code NEC 2017 edition. For motor compressor with a part winding starting, this is the first half of the winding is Y, and the second half is Y. So that's why it is called part winding. And in total, it is just a Y connected motor winding. Branch circuit selection current, same 24.1. That is also greater than the rated load ampere, 17.9 ampere. So I conductor therefore is 24.1 times 1.25. I conductor equals to 30.1 ampere. So this time using the table, we have to use 2 by 5.5 mm squared. Either THW or THSN, stranded copper conductor with 35 ampere and 35 ampere ampacity respectively. So as in my previous video lecture, using table of conductor ampacities, table 310.15b16, to get the conductor size, just see and watch also my video lecture number 1, keeping in mind and ensuring related code requirements are complied. So it is there. Just go back to my previous videos so that you will learn how to get the size of conductor from the table. Now let us go to the code rule for the branch circuit, short circuit and ground protection, or our overcurrent protection device or circuit breaker. The code states application and selection, rating or setting for individual motor compressor. The motor compressor, branch circuit, short circuit, and ground fault protection device shall be capable of carrying the starting current of the motor. A protective device having a rating or setting not exceeding 175% of the motor compressor rated load current or branch circuit selection current, whichever is greater, shall be permitted provided that where the protection specified is not sufficient for the starting current of the motor, the rating or setting shall be permitted to be increased but shall not exceed 225% of the motor rated load current or branch circuit selection current, whichever is greater. Also as an exception, the rating of the branch circuit, short circuit, and ground fault protective device shall not be required to be less than 15 amperes. So, to get the breaker, the overcurrent protection device, you have to multiply the rated load current or branch circuit selection current. So whichever is greater, you will use that and multiply by 175%. And don't forget also that the code uh, suggests that if the breaker is tripping due to overcurrent, so there is an option that you can use another factor, which is 225%. So again, you have to multiply that value to either rated load current or branch circuit selection current, so that the amperage of your breaker or your overcurrent protection will be higher, so that your motor compressor will be able to start. Now for the calculations, branch circuit, short circuit, and ground fault protection. From the motor compressor given nameplate, branch circuit selection current still we have to use because this is greater than the rated load ampere. So I OCPD or overcurrent protection device equals to 24.1 times 1.75. So this comes out to be 42.2 ampere. So here we have to use the standard circuit breaker ratings. So from the table, in my previous videos also, you will see that you have to use 45 ampere trip, 2 pole, 50 ampere frame, and this 15 kaig or 15 kiloampere interrupting capacity. This is still temporary because this value of 15 kaig will have to be calculated during the short circuit calculations, as explained also in my previous videos. And this breaker that we are going to use is MCCB, or molded case circuit breaker. In case of motor compressor fails to start during tripping, this is the option. So again, branch circuit selection current 24.1 multiplied by 2.25 as mentioned by the code. So it comes out to be 54.2 ampere. So in this case, using the standard breaker rating, we have to use 60 ampere trip, 2 pole, 100 ampere frame, and again a temporary value of 15 Ki until later it will be confirmed by short circuit calculations and also MCCB. As in my previous video, lecture number 1, using table 240.6a standard ampere ratings for fuses and inverse circuit breakers, keeping in mind and ensuring related code requirements are complied. Now let us go to the code rule disconnecting means. So rating and interrupting capacity. So for the hermetic refrigerant motor compressor, a disconnecting means servicing as a hermetic refrigerant motor compressor shall be selected on the basis of the nameplate, rated load current, or branch circuit selection current, whichever is greater, and lap rotor current respectively of the motor compressor as follows. So here the ampere rating shall be at least 115% of the nameplate, rated load current, or branch circuit selection current, whichever is greater. So here also provided exception: a listed unfused motor circuit switch without fuse holders having a horsepower rating not less than the equivalent horsepower determined in accordance with 440.12a2 shall be permitted to have an ampere rating less than 115% of the specified current. So take note of this factor, 115%. Now let us go to the calculations. Disconnecting means or isolator. So from the motor compressor given nameplate, again we have to use the branch circuit selection current because this is greater than the rated load ampere. So I disconnect, or I for the isolator, is equal to 24.1 times 1.15, which comes out to be 27.7. And using the standard breaker rating for isolator, we have to use 30 ampere 2 pole 50 ampere frame, again temporary 15 kaig MCCB. As in previous video lecture number 1, using table 240.6a, again standard ampere rating for fuses and inverse time circuit breakers listed as isolators by OEM, and also keep in mind and ensure that the related code requirements are complied. Now going to the code rule for the motor compressor and branch circuit overload protection. So Article 440.52 Application and Selection Protection of Motor Compressor by one of the following means. So one option is a separate overload relay that is responsive to motor compressor current. This device shall be selected to trip at not more than 140% of the motor compressor rated load current. So take note of this factor. For the overload, one option is apply 140% to the rated load current. So this time only rated load current. And number 2, thermal protector integral with the motor compressor, approved for use with the motor compressor that it protects on the basis that it will prevent dangerous overheating of the motor compressor due to overload and failure to start. If the current interrupting device is separate from the motor compressor and its control circuit is operated by a protective device integral with the motor compressor, it shall be arranged so that the opening of the control circuit will result in the interruption of current to the motor compressor. Number 3, a fuse or inverse time circuit breaker responsive to the motor current, which shall also be permitted to serve as the branch circuit, short circuit, and ground fault protective device. This device shall be rated at not more than 125% of the motor compressor rated load current, and it shall have sufficient time delay to permit the motor compressor to start and accelerate its load. The equipment or the motor compressor shall be marked with this maximum branch circuit fuse or inverse time circuit breaker rating. And number 4, a protective system furnished or specified and approved for use with a motor compressor that it protects on the basis that it will prevent dangerous overheating of the motor compressor due to overload and failure to start. If the current interrupting device is separate from the motor compressor and its control circuit is operated by a protected device that is not integral with the current interrupting device, it shall be arranged so that the opening of the control circuit will result in the interruption of current to the motor compressor. So there are 4 options. So here we will discuss only option number 1 and option number 3. So for option number 1, from motor compressor given nameplate, so we are using this time only rated load amperes, which is 17.9 amperes. So I overload is equal to 17.9 times 1.40 comes out to be 25 ampere. This is now the setting which shall be not more than this value. So the next step is a similar as in previous motor video lecture number 4 episode, using tables from manufacturer's OEM or original equipment manufacturer. Select the proper overload device and keeping in mind and ensuring related code requirements are complied. Now for option 2, which is the thermal protector, this is usually provided by the manufacturers, which is integral with the motor. For option 3, from motor compressor given nameplate, rated load amperes is equal to 17.9 amperes. So current of fuse or I of fuse or ITCB, inverse time current circuit breaker, is equal to 17.9 times 1.25. So that comes out to be 22.4 amperes. And also it shall have sufficient time delay to permit the motor compressor to start and accelerate its load. And option 4, uh, just follow the code rule as specified and apply the factors provided. Now for the final summary, so here we can see the complete circuit and our result of calculations. So here the branch circuit conductors and also the equipment grounding conductors, which I mentioned here. So here we have to use either 3.5 square mm THW 25 ampere ampacity or 5.5 square mm PHHN 30 ampere ampacity copper conductor. For the equipment grounding conductor, this was also discussed in my previous video, so just go back and review. It is explained there and it is easy to understand. And also the short circuit and ground fault protection, which is our OCPD, we have to use 45 ampere trip, 2 pole 50 ampere frame 15 kaik MCCB. And if it is not sufficient to start the motor, we have another option of 60 ampere trip maximum as per our result in our calculation. And also disconnecting means from the previous calculation, we have to use 30 ampere, 2 pole, 50 ampere frame, 15 kaik MCCB. And for the controller and overload device, for the overload range, we have to use 20 ampere to 25 ampere. And the settings should be not more than 25 amperes. And the last, for the motor compressor nameplate is given as 3.5 ton or 12 kilowatt, 230 volts. The rated load ampere is 17.9. The lock rotor ampere is 112 ampere. And the minimum circuit ampacity is 24.1, which is also the same as branch circuit selection current. So here, as we can see in the summary of the circuit, that all the values matches. So if you see, the conductor ampacity is 25 ampere minimum. So which is also matching with the disconnecting means, which is 30 ampere. And it is also matching with the overload setting, which is 25 ampere. So if for example you are using the minimum conductor of 25 ampere ampacity, so the overload will operate and it will protect the circuit. Also, the disconnecting means is just enough. It is having a 30 ampere ampacity. So either you will use the conductor 25 ampere ampacity or 30 ampere capacity. The disconnecting mean still works. And the breaker, of course, it will have a higher ampere trip because this is a short circuit and ground fault protection, and our load is a motor, and it is not just a motor, it is a motor compressor which is used for refrigeration and air conditioning equipment. So I hope that you learned something. Thank you and God bless.